Hello again, everybody. This is Tom from Every Step Calculus, EveryStepPhysics.com. I'm going to do a problem in physics regarding an Atwood machine. That's where two masses are on each side of a pulley connected with a string across the pulley. And this is going to include the mass and the radius of the actual pulley. Pretty complicated if you didn't have a program or didn't really know how to study it like for 2 weeks like I do to do these things. So anyways, let's do it. Physics, and then open and close parentheses to get to my physics menu. And we're already at Atwood Machine here, so we're going to scroll to that. And we're going to choose what they give you is the M1, M2, which is mass 1 and mass 2. And then they give you another mass for the pulley. So that shows up here so that you can choose it. You scroll down to it. You can press the number 2 on button, but scroll down to it. At Atwood Machine with pulley involved, okay. We're going to enter the first mass. You have to press alpha first before you enter anything in these entry lines of my programs. Okay, so we're going to go alpha, given as 13. And we're going to choose number 2, kilograms. Second mass is given as alpha 22 kilograms. The mass of the pulley is alpha 9.2 kilograms, and the radius is given as alpha 0.2 meters. So we're going to choose number 3. I always show you what you've entered. You can change it if you want. I say it's okay. First what we find is moment of inertia. All these discs and pulleys and cylinders and rods all have a moment of inertia, which is intrinsic to that particular form of steel or whatever. And that turns out to be like the mass 3 times the radius divided by 2. And turns out to be 0.184 kilograms per meter squared. That's the moment of inertia. I is the SI unit for moment of inertia. So now I show you Newton's second law, which is this involved with F net equals mass times acceleration. And we're going to find or at least show you right now, we'll find the tension later, but right now I'm showing you the tension of the string connected to mass 1. And so here's the formula here. Mass, this is M1 times G, which is really the force of gravity. And mass 1 equals mass 1, Newton's thing. So the force minus the force of gravity, T1 minus the force of gravity is equal to M1A, mass times acceleration, etc. We put in the variables that we know, and we come up with the first equation, which is 13A plus 127.53. Do the same thing for tension 2 on the other side of the pulley. Turns out to be 215.82 minus 22A, which is mass here of the second mass. A little bit about the torque. The torque of the pulley is equal to the angular acceleration, which is equal to what we just found, the moment of inertia times acceleration. It's also equal to the force applied to something round or a cylinder or a pulley by its radius. And then the torques are all added. In this case, one is subtracted because you got one mass on one side of the pulley and one mass on the other side. When one goes down, the other one goes up, so they have to be different. So this just turns out to be the angular acceleration here. And so then if you multiply it times r, the forces, T1 force times T times r, you get that angular acceleration. Now A is linear acceleration, and that equals the alpha, which is angular acceleration, times the radius. So alpha, if you want to change one to the other, and here I'm showing you that alpha, which is the angular acceleration, you can divide the acceleration by r, the linear acceleration by radius, and change to that, which is one of the tricks that they do when they show you these problems. It took me quite a while to figure that out, because they just show you this in their formulas as these professors show you what to do, but it doesn't explain where they got it from, or so that you can remember how to do it, and I need to know everything about it when I program these things. So then here we go, we're going to transpose the r to the other side, multiply T2 minus T1, tension 2 minus tension 1, by the radius, and so we transpose it, and we subtract it, or divide it on the other side, okay? So, and then we work it out here, the unknowns that we have, or the knowns that we have, and we get 4.6 times the acceleration. We substitute these Ti and T2, now what we found earlier, into the equation. Here's T2, and here's T1. Now minus times the quantity of T1, so this has to be, this reason I did it twice here, because you have to change this sign here to minus 13A and minus 128. And that equals the angular acceleration, linear acceleration actually. So now we have regular A is linear acceleration, remember that, okay? And we combine those terms in the previous screen here and come up with 88.3 minus 35A equals the linear acceleration, etc. And we come up with the A is equal to 2.2295 meters per second squared, which indicates that it is linear acceleration. If it wasn't, if it was angular, it'd be rads per second, radians per second squared. So we found the acceleration for the system, okay? We go on, we find the tensions. The tension is M1A plus M1 times G, gravitational acceleration, which is 9.81 meters per second squared. And we do the calculation, we come up with this. We do the calculation for T2, we come up with 166.77 newtons, okay? And the angular acceleration we can convert to from linear to angular by doing these calculations. The linear divided by the radius, 11.148 radians per square second squared. So there you have it. We have a new problem. You've just done something very complicated and programmed it. Notice that I can do this now forever, as long as I have the TI89 Titanium. And if you just put it in notes, you'd never be able to do it. Plus, you can change the variables that they give, so you can go anywhere and put the new variables in, and it'll come up with the proper answers. So it's pretty neat, these programs. That's the reason I do programming, because I'm not going to, how could you possibly memorize this for a test? You might have 10 problems in your physics test with an hour to finish it, and this would take you, well, you probably mess up, couldn't even do it really. So keep that in mind, and it's good for your homework too. So everystepphysics.com, go to my site, buy my programs, and pass your physics class, okay? Have a good one.